Today we got a very small oscilloscope. Can be bought on eBay or AliExpress for very cheap. It's a DSO 138, and yeah, let's get started with it. So first of all, it has this signal input, and it can accept voltage from 8 volts to 12 volts, but the standard, like recommended, is 9 volts. We have got a coupling switch. We have a sensitivity switch starting from 10 millivolts to 0.1 volt and 1 volt, and then we have one last switch which is x1, x2 and x3, and it also controls the sensitivity. Sorry, this is broken and it came as it is. So we have this trigger LED, we have a reset, and we cannot power this oscilloscope via this USB because it is for updating the firmware inside the microcontroller, so it's not for the power. And we have selection switch, we have minus, we have plus, and we have the OK switch. So let's power this little oscilloscope on, and yeah, see how it runs, right? So to power this thing up, I have got another item which is a boost converter, and it can boost the 5 volt from my PC to 12 volts, right? So I'll just plug it into my PC, and then let's connect it. So when you connect it, you see the welcome screen booting. Yeah, so very cool interface. I like all the colorful stuff over here. So initially you see a lot of things. It's running. You can see the voltage measurement over here. You can see the triggering on the falling edge, and you can see the auto. I'll talk about this later on. You have this time division, and you have this voltage division. Now let's connect the signal pin. Right, so the easiest way to see how this oscilloscope performs is this pin. You can see that the little square wave, you see. So in here you can have a 1 kilohertz of 3.3 volt square wave on this pin. So that's a good part, and you can see that we have very nice and clean waveform over here. So right now my coupling is set to AC. Sensitivity is 0.1 volts, and this sensitivity to switch is set to x2. When you move to the it's x5. So when you do it x2, the signal increases. On x1 it increases again, so it's kind of sets the impedance. So let's move it back to x5 and like this, right? So you can do a lot of stuff with this oscilloscope, like a basic stuff. So if we press the selection key over here, you can select between different items. Like now this goes to the auto, the next thing would be your trigger, and then you can see that it selects this point, right? This pointer. This one selects the is used to measure the voltage, right? So when you do the plus thing, it goes up, and you can see this value changes, which measures the voltage. So yeah, keep on clicking. And when you are here, you will see that you have voltage of 1.5. So why 1.5? Because it is measuring from the center. So if I change this button from AC to DC, you can see the signal shifts up. Now when you measure this voltage, it will be doing measurement from 0 to the signal wherever it goes up, right? So if I change the voltage division and bring this thing down, and closely to the level of this one, you can see that, and it measures the voltage of 3 volts. So that's what we get, because we have connected this input signal to the 1 kilohertz wave and 3.3 volts. So it's almost there. I haven't calibrated it, so yeah, we can do the calibration and for more precise results. So yeah, again, if we click on the selection key, it goes to the top, this bar. When you do the plus and minus thing, it shifts the signal from left to right, right? So again, as per your need. When you tap the selection key again, it then selects this point, which is actually kind of allowing you to decide what is the center point of your signal. So if I do the plus thing, the signal moves up, yeah, and when you do the minus, the signal moves down like this. Right, so as it is coupling is DC here, so we want it to start from the center point, so that's good. And when you tap the selection button again, it will go back to this time block, and when you increase it, it is going actually, yeah, doing the plus is decreasing the time. It's now 50 microseconds, 20 and 10 is the minimum, right? So yeah, 20, 50, 0.1 ms, 0.2 ms, 0.5, 1 ms, and we have also this triggering mode, auto, right? So when this is set to auto, the screen refreshes no matter it is it gets any trigger or not. It just keeps on refreshing. So yeah, so when you change it to normal, so the screen only refreshes when it gets the trigger, right? Otherwise it's just paused or it's just freezed. And then we have the single mode, SING. So this automatically captures the one signal waveform. So whenever it gets any trigger, like this square waveform gets any trigger, goes from high to low or low to high, it just captures that frame and puts it on the hold automatically. So yeah, so that you can see the single waveform. So yeah, so these are 3 modes: the normal mode and the auto mode, right? So to release it from the hold, you can just press the OK, and to put the screen on hold anytime, you can just press the OK button and it will be on hold. Yeah, and press it hold again to resume it. For precise measurements, you can also calibrate this oscilloscope, and we'll try to do that as per instructions given in the manual. So the first things you would notice is that you gotta keep this voltage deviation to 0.5, and this can be AC or DC. This can be changed via this switch, so I'm keeping it just AC. This should be 0.2 milliseconds. This is auto, and we have this falling edge, or it can be rising edge, whatever, right? And the other things don't really matter. So the first step towards the first part of calibration is to set this sensitivity to 0.1, and this second sensitivity is switched to X5 over here, and then you need to change this C4 to get a sharper waveform over here. So let's try to change it and see what happens. Yeah, you can see some jitter and not much changes that I can see over there. So I'm just going all around, and yeah, I think it's pretty much the same, so it doesn't really matter. So that's one thing. And the number two is to change this sensitivity switch to 1 volt like this, and then the sensitivity 2 to X1 over here. So you see again a waveform, and now you can change this capacitor C6 to again get some sharper waveforms over here. So let's change it, and yeah, we don't want to see these spikes over here. So I'm just trying how to get rid of those spikes, but I guess nothing is happening. Try to change C4. No. Not much. If we do DC, now, so anyways, it doesn't do much for the calibration, but yeah. So according to the manual, we shouldn't see any of these spikes, and the waveform should be smoother, but I guess none of these variable capacitors is working to change the waveform quite